So all of you know how to find the mean. So if I asked you like to average some numbers together, you would tell me to simply add up all the numbers and divide by how many numbers you added together, correct? So you're doing the same thing. So we call that the arithmetic mean. And you're going to see now, since we're dealing with statistics, we have different symbols that we use for statistics. So instead of saying, or writing the word mean, you're going to see this Greek letter right here. So if you look at your formula sheet, because you should have these side by side, you'll see a key on your formula sheet that tells you this represents the mean. How many people see that? All right, so now that's a Greek letter, and it's on your formula sheet that says mu, which represents the mean. So that's how we're going to actually say that. That's mu. Mu stands for what? Mean. So we're just going to be using some different words for something that you already know how to do, and it's going to be written this way. So yes, to find the average or the mean of a set of numbers, we do add them all together and we divide by how many numbers we have. So I want you to be able to read these Greek symbols. So see this symbol right here? This symbol, if you look on your formula sheet, is what? Sigma. Very good. So that is the Greek letter for sigma. Okay, sigma, if you look at the sheet again, says summation notation. So what does that mean? It means take the sum. Okay, that's all big sigma represent, because there's also a little sigma. You know how in our alphabet we have capital letters and lowercase letters? Same thing for the Greek alphabet. So we have big sigma, which is this one, and then we have little sigma, but both of them we just say sigma. Just like we have capital A and lowercase a, we don't say capital A and lowercase a, we just say A. So same concept. Now this right here, okay, look on your formula sheet. What does X of I represent? Yes, what does it represent though? Element in your data. So that's just your data. So that means that's just your numbers. So right here, this will be data, 2, 5, 8, 9, 12. So those will be those numbers. So and then N, okay, take a look at your sheet again. What do they tell you N represent? The number of items you have in your data. Okay, and that makes sense. N stands for the number of items you have in your data. So you have to know how to read the formula in order to even use it when we get down to some of the other ones. But you know how to find the mean. And this is saying the exact same thing. It says take the sum, because remember big sum means sum. That means add up all of your data. Add up all of your data and divide by how many numbers you have in your data. That's how we find the mean. Okay, it's just written a little differently now. Okay, but you guys know how to find an average of a set of numbers. But you have to be able to read this. Now you will be given these formulas when you take your SOL test. So that's the good thing. You'll be given the formula, but you got to know how to use it. Okay, so formulas aren't any good if you don't know what these little symbols represent. All right, so let's do the median. So these are things we already know how to do. Median is the middle number. Okay, and your data. Now your data has to be in order. So if we were looking at an odd set of numbers, then my middle number is 8. Okay, so that's your median number. We've done mode before, so that's your most frequently used number. Okay, you can have no mode at all if each number appears once. Okay, now if the 8 was also repeating 2 times, I could have 5 as the mode and 8 as the mode. You could have more than one mode if they repeat the same number of times. Okay, range is something that we're familiar with. That's just taking the difference between the least and greatest numbers. Okay, so I think you guys are familiar with range. Just take your greatest number, your least number, subtract them. And so all of those actually have, if you actually put all of these together, the mean, the median, the mode, and the range, they have a name when you put them all together. It's called measures of central tendency. So I'm going to write that up here. Measures of central tendency. I need to move this up here. So measures of central tendency just simply means mean, median, mode, and range. Now, we have some new words. So from here to here, including the word range, we call those measures of dispersion. Okay, so that's what now, so we have the top part called measure of central tendency. We have this bottom part, but notice range is in both areas. It's called the measure of dispersion. Now, the measure of dispersion, and notice it's just going to be a measure that describes how your data is spread out or dispersed. So that's where you get the dispersion. So we're going to say how it describes how dispersed or spread out. Okay, that's another name for dispersed, spread out. The values in a data set are, how much they're spread out. Now, when we are comparing how they're spread out, we're going to always be comparing everything to the mean, okay, to the average. Okay, so that's what we're going to be, it's going to be relative to the mean, right? So that's all of this stuff is going to be just taking your data and you're going to analyze how it's spread out based on the mean. So the first one is called mean absolute deviation. And we abbreviate that because that is a lot to say. We just abbreviate it MAD. All right, and you will see this. It'll ask you on your test, like, what is the mean absolute deviation of this set of data? So, again, it shows on average. Okay, so again, we're comparing it to the mean. I'm just going to abbreviate average this time. How far the data values are from the mean. Now, I want you to take a look at this formula, okay? So now, instead of just adding up, because sum again means to add, this big sigma, instead of just adding up all the x values, it's telling you to take the x values, all of your data, subtract it from, what does this represent? The mean. Okay, and what are these bars on the outside? And take the absolute value of all of those. Okay, and then divide it by how many numbers you have in your data. All right, and we're going to follow that process in a minute, so because you got to be able to, again, to read what it's asking you to do. Okay, variance. Variance, again, is the average of the squared deviation. Because you can see it in the formula. So now they're taking the x minus the average, squaring it, adding all of those up together. That big sigma means to take the sum and divide by how many numbers. And notice the symbol. This is little sigma squared. So that, you know how we had, this is big sigma, this is little sigma. Okay? So that's the Greek letter or Greek symbol, that is, for sigma as well. So variance is squared, and notice even this is squared and this is squared. Can you tell me the difference between these two? I still see sigma here, but it's just not what? Squared. But what do you notice here? It's a square root. So technically, if you know the variance, you could just take the square root of the variance, and guess what? You'll have your standard deviation. Okay? So standard deviation shows how your data varies or deviates from the mean. Everything is just comparing it to the mean. Okay. Have you guys ever heard of a bell curve before? Okay. Or some people say they grade on a curve. Okay. Usually when you get in college, you'll hear things like that. But we're going to be talking about bell curves. And really, this makes more sense. And I'll show you in a second just a quick description of what they mean by varies from or deviates from the mean. I'll show you that. Okay, let me do that now. So here's a bell curve, and this will be part of your project you're going to have to do. So the mean is always in the middle of the bell curve, and then you'll have some data points or numbers out here. So let's say this was 100, and this is 110, 120, 130, and let's go this way. So when I go to the left, I actually subtract. So let's say this is 90, 80, 70. So the difference from here to here and to here to here and here to here is what? All right, so this is plus 10 on this side and minus 10 on that side. Is that correct? So that's the standard deviation. It's the scale you use to get from this number to this number to this number to this number. So the standard deviation I was using was 10. Okay, so that's what the standard deviation is like. What are you counting by to get to the next number on your bell curve? So that's standard deviation. But notice again, it's relative to what? The mean. Okay, it's relative to the mean. And that'll make a little bit more sense to you when we actually do a whole lesson just on bell curves. Okay, but that gives you some idea what it is. All right, the last one is z-score. So that is the position derived from the mean and the standard deviation. So it really tells you where you actually are landing on the bell curve. Okay, so for instance, let me just go back to the bell curve because this makes more sense. So if I land somewhere in here on the bell curve and I'm not exactly at 110 or 120, then I can get what I call a z-score. That means where am I positioned on this bell curve. So what we do is we call this one standard deviation. Okay, so that's a plus 1. This will be a plus 2. So if I'm in the middle of plus 1 and plus 2, then I'm at 1.5. Is that correct? So that will be your z-score, 1.5. So it tells you where you actually land, when it's not directly here. It tells you exactly where you are on the bell curve. And again, that'll make more sense when we have that whole lesson about bell curves. But it, gives you some kind of, idea of what it is. All right, so let's do this. So we got our vocabulary going. What we're going to do is start with this page here. This is the page that was just passed out to you. And we're going to start with doing variance. And I want to do all three because for homework, you're going to have to give me the mean, the variance, the standard deviation, and the MAD. So let's just go ahead and add MAD to this table here. Okay, that's the mean absolute deviation. Okay. And let's just go ahead and add another row to this because we're going to need another column since we're going to do that. And then we can just do it all at the same time. Okay. Okay, so let's read the question. Well, it says the table below shows the ages of dogs available adoption at the Fairfax County shelter last week. You found that the mean age for these dogs is 4.082 years, which will round to 4. None of the dogs is exactly that age. Okay, because here are the ages right here. So how much older are these dogs on average than 4? That is the question. Okay. So what we're going to do is we're going to make a table because we have to use these formulas that we just looked at to come up with the variance, the standard deviation, and then I did add the the MAD as well. Okay, so what I'm going to do is have you guys add up all of the dogs' years first, or ages that is, and see what you get as a total so we can find out the mean. Because remember, you just simply take all of your numbers, add them together. Okay, and I'm going to get a total right here. And you guys should get 44.9. All right, so remember, that's just the total. So now we're going to take that and divide it by how many dogs do we have. How many do we have? So we have a total of 11, so that's going to be 44.9 divided by 11. And they already told us that the answer was 4.082. They already told us that in the problem, which is, we're going to say approximately 4. So notice I did like a little squiggly equal sign, which stands for approximately. Okay. All right, so this is how we're going to make our table. So when you have to give me these things, then this is what you're going to do to make your table. So this, in the first label, you're going to have your x of I minus mu. Okay, remember mu is the mean. This will always be in your table. Okay, so I'm going to just write always, so you'll know that's always the first thing you put in your table is that. That's going to always be there. Okay, now since I'm looking for variance, and according to my formula, variance is squared, I'm going to make this x of I minus mu squared. Because if you go back to the formula, it is squared, correct? Is that a yes? All right, and then since the MAD is absolute value, then I'm just going to put absolute value of x minus mu in that column. So I'll have the squared column and the absolute value column. And that's going to give me this number and this number here, right? Now, I'm going to show you how you can get standard deviation in a minute. Because remember I said, if you know the variance, all you have to do is take the square root and it'll give you the standard deviation. How many people remember me saying that? Very good. So if this is squared and this is not, then that means all I have to do is just take the square root to go from here to here. All right? Okay, so let's do this. So first what we need to do, this is like your x of I column. These are your data. That's your data. Right there. All of those numbers would be your x of i's. 7, 4.5, 3, and so on. I already found out that I rounded the mean to what? To 4. So all I'm going to do is take all of these numbers and subtract what? 4. That's what it's telling me to do. Take your x of I, subtract 4. Take your x of I number, subtract 4. Okay, so 7 minus 4 is 3. Okay, 4.4 minus 4, 0.5. 3 minus 4, negative 1. 2.6 minus 4, negative 1.4. 0.75 minus 4, negative 3.25. 2.1 minus 4, negative 1.9. 3.2 minus 4, negative 0.8. 9 minus 4, 5. 6 minus 4, 2. 1.2 minus 4, negative 2.75. 5.5 minus 4, 1.5. Okay, now you don't need to add up that column. Okay, so now all I need to do is square all of the numbers. So I don't need to do it again. I just need to take this number and square it. Isn't that true? Right, so 3 squared, 0.5 squared, negative 1 squared. So all of these are going to be positive numbers. So I'm going to have 9.25, 1, 1.96, 10.56, 3.61, 0.64, 25, 4, 7.56, and 2.25. Okay. Now I do need to get a total for this column because remember, variance is saying to take all of those numbers, add them together, and divide by 11. Okay, so somebody give me a total for this column here. I need a total. All right, are you guys getting 65.83? All right, so there's my total. So remember, Big Sigma says take all of those, add them together, which I just did, and divide by 11. That should give you approximately 5.98. Is that correct? 5.98. Okay. Which is approximately 6, but we're going to be using that 5.98 to go from variance to standard deviation. All right, any questions what I've done so far? Okay, all right, so to go from variance to standard deviation, all I have to do now is take the square root of the 5.98. Okay, that should give us 2.44. Okay, which is approximately 2. How many people got that? 2.44? Yes? All right, great. Absolutely. Okay. So now the only column I need to do is this column. Correct? So I already did, my initial work, which was subtracting these. So really, I just take this column right here and make them all what? Positives, because it said take the absolute value. So I'm just going to write the same numbers, but I'm just going to make sure they're all positives. So I need somebody to add those up. I don't have that total yet. Okay, let's see, can we verify that? Did somebody get the same answer? Okay, let's verify it, because I don't have that one written down. All right, we got a different answer. How much? 23 point. All right, so 23.1. So we're going to take that number and divide it by what? 11. All right, so we take 23.1, divide by 11. What do you guys get? All right, there's our answer. Okay, see how we did that? Okay, 2.1. Now, which is approximately 2. So what I'm going to have you guys do is we can, if you look on that formula sheet again, you'll see something that says X bar. But notice X bar is not in any of the equations. So I want you to put by X bar, this is for calculator only. Okay, so this is for the calculator. The calculator does not do the mu. It does X bar for the mean. So I'm going to show you what it looks like on the calculator. So that X bar that's on your formula sheet is only for calculator. So that's what the calculator uses. And then I'm going to show you the symbol that looks like this with an X for the calculator. That's going to equal the standard deviation. Okay, write that down somewhere, guys, so you'll know which symbol on the calculator represents standard deviation. It's going to be little sigma, and it has like a little X by it. Okay, like a little sub X, because it's kind of under it. All right, so on the calculator, that will represent your standard deviation. So now let's go to the calculator. Okay, if everybody would go to their calculator, I'm going to show you how to clear your list without having to like put it on L1. So everybody hit second. Let me clear this first. Second plus sign, and then you can do option number 4 and enter. So you can do second plus sign, option 4, and then hit enter. That will also clear all your list at one time. Okay, second plus sign 4 enter. If you want to write that down, might be a good idea. If not, you could just clear it like we did before, where you put the cursor on it, hit clear, and bring it down. All right, so hit stat and enter. And then what you're going to do is, and I'm not going to type in the same numbers, so you're going to type in the ages of the dogs. Okay, well, maybe I will. I'll go ahead and type it in. So 7, 4.5, 3, 2.6, 0.75, and I'll just keep going. Okay, so all we're doing is inputting the data. Okay, all right. So once you get your data in, you're going to go back to stat. Okay, let me just clear this out so you can see my steps. All right, so once you have your data in, you're going to go back to stat. You're going to cursor over to the top that says calc, arrow over, and you should already be at option 1, which is where we want to be, so we're just going to hit enter. Okay, you're going to hit enter 3 times until you see some numbers. Okay, everybody see that? All right, so remember, your calculator doesn't use mu, it uses X bar for the mean. Didn't we get 4.082 for the mean? That's how you can check it. The other number that we got was this number right here. Little sigma x equals 2.44. What do we call that? Standard what? Standard deviation. So like on a bell curve, they're counting by 2.44 each time to get to the next number. That is the standard deviation. The n, what does n represent? The number of items or data points you have. Okay, so that n can let you know that you did put in 11 numbers. The rest of the stuff we're not going to use. Okay, so you're using X bar for the mean. You're using this number here, which is your standard deviation number. But guess what, guys? If the calculator gives you standard deviation, okay, let's go back. I want you to think about the math on this one. If the calculator gives you this number, which is standard deviation, how do you get this number? Just square it. Exactly. Who said that? Very good. So if you know the standard deviation, you square that number, guess what? You have the variance. Okay, everybody put 2.44 squared on the calculator. So people say, oh, well, the calculator doesn't give us variance. Well, it gives you standard deviation. You can just square that number and have your variance. Did you guys get approximately 5.98? There you go. Okay, so those things you can check with your calculator. And again, guys, as I always do, your calculator does not substitute for your work. Okay, you still have to show me this process, but this is how you can check on your calculator. All right. All right, so let's answer these questions at the bottom. Okay, then we'll be done. So it says the average sum of these values. So when we did the variance, okay, because this is actually the variance. Okay, we did, it came out to be approximately 6. Okay, it was 5.98. So when you take the variance and you take the square root, then you have the standard deviation. Okay, that came out to be approximately 2. Is that correct? Okay, 2.44 to be exact. So that means, on average, the dogs at the shelter are about 2 years older or younger than the average age of 4. Because remember, 4 is like in the middle of that bell curve. So if you're looking at a bell curve, 4 would be in the middle. Okay? And on average, they go out, each standard deviation is approximately 2. So that would be like 6 years, 8 years. It tells you how to count. Okay? 2 years, 0 years, and so on. Okay? So that kind of helps you out to get a little visual picture of what that means. Right? Okay, guys, so that's the lesson, and it gives you, again, the only thing we didn't cover today really is z-scores. Okay, so we did the mean, we did the variance, we did the standard deviation, and we did the mean absolute deviation. So I'm going to tell you for what you're doing in your homework. So if you would go to page 6 in the staple packet, okay, page 6, and on page 6, you'll see I already did the dogs. So I want you to just transfer the answers. And let me see, can I pull this up? Yeah, let me go to page 6 so you can see it. So right here, guys, this is what I just did. So I just calculated the mean, the MAD, standard deviation, and variance for this column here. Okay, what you're going to do for homework would be the next 2 columns. So all I want you to do is transfer the answers that we just got for the dogs' ages here. Right, and let me see, I want to make sure that we're all rounding to the same thing. So hold on one second. So you're going to do the weight of offensive linemen. You might want to do this on graph paper, so the lines will already be there for you, because you got to make that same chart that I did. Your chart is going to look exactly like mine, okay, with those columns in it. So you're going to do the exact same chart. So let's just round to the tenths place. I'll let you do tenths or hundreds. It doesn't matter. If it's off by a little bit, that's fine, okay? I was trying to find my answer key, but I can't find it to see what I had round to, so we'll be together. Well, let's do the hundreds. Let's do the hundreds, and then we'll be consistent. So what you're going to do now, if you feel like you can do one of the tables here, that's fine. And then the one for Meredith's test scores, you can use the space at the bottom. That's up to you. Or you can just use graph paper and make your 2 tables and figure out those values. Okay.